Hi, this is Algebra 1, Lesson 88. We're going to talk about quadratic equations, solutions of quadratic equations by factoring, and we're starting on 367. Quadratic equations are second-degree polynomial equations. For example, 4 minus 3x equals 2x squared, or 3x squared minus 2x plus 4 equals 0. This is actually the standard form for quadratic equations. So when we're working with quadratic equations, we need to start by getting them into this form. All the non-zero terms are on one side of the equal sign, and on the other side there's just a 0. And it's written in descending exponent factors. So the square, then x to the 1, and then x to the 0, or no x here. Okay, so these are also in standard form. 4x squared equals 0, 4x squared plus 2x equals 0, or 4x squared minus 3 equals 0. Those would all be considered in standard form. The general quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c are any real number. Okay, so here's an example. We have x squared minus 3x minus 10 equals 0. So in this case, our a is actually an implied 1, right? Our b is a negative 3, and our c is a negative 10. So if x equaled 5, then we could rewrite this as 5 squared minus 3 times 5 minus 10 equals 0. And we can work this out and see if this is a true statement. We would have 25 minus 15 minus 10 equals 0. And this is 10 minus 10 equals 0, which is true. Right? If x equaled if x equaled negative 2, so here x equals 5. Over here, let's try x equals negative 2. If x equals negative 2, then this is negative 2 squared minus 3 times negative 2 minus 10 equals 0. Negative 2 squared is 4. Negative 3 times negative 2 is positive 6. Minus 10 equals 0. And this is 10 minus 10, which does in fact equal 0. So this is also true. As it turns out, 5 and negative 2 are the only numbers that will satisfy this equation. Every quadratic equation has at most 2 distinct numbers that will make the equation a true statement. Every third-degree polynomial equation in one variable has at most 3 distinct numbers that will satisfy the equation. Every fourth-degree polynomial equation has at most 4, etc., etc., etc. Okay, so let's talk about finding solutions of quadratic equations by factoring. We're going to start by talking about the zero-factor theorem. And that says if p and q are any real number, and if p times q equals 0, then either p equals 0, or q equals 0, or they both equal 0. Here are some examples. We have 4x equals 0. Obviously, in this case, the 4 can't equal 0. It's not a variable. 4 equals 4. So the x must equal 0. Okay? But in this example, we have xy equals 0. Here we have 2 variables, and we don't know which one is the 0 or if they are both 0. So the answer to this is x equals 0 or y equals 0. Okay? Now we have x minus 3 times x plus 5 equals 0. Okay, now we have 2 terms, and we know that one of them has to equal 0. And it's not the x that's going to equal 0, it's the entire term. If the x equals 0, then this term is just equals negative 3. If this x is 0, then this term is 5. So it's not the x that's going to equal 0, it's the entire term. So we could solve this by saying x minus 3 equals 0 or x plus 5 equals 0. And now we can solve for x for both of these terms. So if x minus 3 equals 0, then we can add 3 to both sides and say x equals 3. So in order for this term to equal 0, x has to equal 3. Or for this term to equal 0, x has to equal negative 5. And this would be your answer. X equals 3 or x equals negative 5. We will use the zero factor theorem to solve quadratic equations that can be factored. So here we have x squared minus 18 equals 3x. So we're going to start by putting this in standard form with all of these numbers on the left and a 0 on the right. So we're going to subtract 3x from this side. And we'll have x squared minus 3x minus 18 equals 0. Okay? Now we need to try to factor this. We're going to factor it into two terms. Do not lose the equals 0. This is x squared, so both of these are going to be x's. We have two negatives. That means because this one's a negative, it means that one of these is going to be positive and one of them is going to be negative. So now we need factors of 18, of negative 18, that are going to add up to negative 3. So the factors of negative 18 are negative 18 and positive 1, or negative 1 and positive 18. We have negative 2 and positive 9, or negative 9 and positive 2. We have negative 3 and positive 6. That would give us a positive 3. Or we have negative 6 and positive 3, and that would give us a negative 3. So we'll use that one. Negative 6, positive 3. Okay? So this is the factored form of this. Now we're going to solve for x. So either x plus 3 equals 0 or x minus 6 equals 0. So we're going to set them both to 0. And we'll have two solutions for x. In this case, x equals negative 3. And in this case, x equals positive 6. So that will be your answer. Okay, in this example, they just reworded it. So it says, find the roots of negative 25 minus 4x squared. That's the same thing as saying, find the factored values of x. So we're going to do the same thing. We need to get both terms on the same side. So if I add 4x squared to both sides, we'll end up with a 0 here, and 4x squared minus 25 on this side. Okay? Now we have the difference of two squares. So on this side, it's going to be 2x minus 5, and on this side, it's going to be 2x plus 5. Okay? Now we're going to set both the terms, I didn't need that parenthesis, equal to 0. Okay, and now we're going to solve for x. So plus 5 here, and 2x equals 5. Divide both sides by 2, and x equals 5 halves. Okay, on this side we're going to subtract 5 from both sides. We get 2x equals negative 5. Divide by 2. And x equals negative 5 halves. and that would be your answer. Okay, here are two more. And at the end, when we find the answers, we're going to go back and check them. You guys, you need to be checking your answers to make sure they're true. So, here we have solve 3x squared minus 6x equals 9. We need to get everything on the same side of the equation, of the equal sign. So we have 3x squared minus 6x minus 9 equals 0. The first thing we can do is factor out a 3. This will make life much easier when it comes to factoring these equations. So we put a 3 in front, and then we divided each of the terms by 3. So 3x squared divided by 3 is x squared. Negative 6x divided by 3 is negative 2. And negative 9 divided by 3 is negative 3. All equal to 0. Now don't lose that 3 out front. Now we can factor the trinomial in the parentheses. So this is x squared, so both of these are going to be x's. This is a negative, so one of these is going to be positive and one of them is going to be negative. This is a negative, so we need factors of negative 3 that add to negative 2. The only factors of negative 3 are 3 and 1, so we are going to have negative 3 and positive 1, or negative 1 and positive 3. In this case, we're going to have negative 3 and positive 1. Okay? Okay. 3 cannot equal 0. So in our final part of this, when we're doing our zero factor theorem, we can ignore the 3. So x plus 1 equals 0, or x minus 3 equals 0. And x equals negative 1, or x equals positive 3. Okay, now we're going to check. We're going to put both of these back into the original problem and make sure that they give us true statements. So if x equals negative 1, then the original statement was 3 times negative 1 squared minus 6 times negative 1 minus 9 equals 0. Negative 1 squared is 1, so this is going to be 3. Negative 6 times negative 1 is positive 6 minus 9 equals 0, and this is 9 minus 9 equals 0, which is true. Alright, let's check 3 and see if it works. So we have 3 times 3 squared minus 6 times 3 minus 9 equals 0. 3 squared is 9, so this is 3 times 9, which is 27. Minus 6 times 3 is 18. Minus 9 equals 0. 27 minus 18 is 9. So 9 minus 9 equals 0, which is true. So both of these are correct values of x. Okay, here's another one. Find the values of x that satisfy x minus 56 equals negative x squared. Let's start by getting the x squared term on this side. So we have x squared plus x minus 56 equals 0. Okay, now we can factor it. Here we have x squared, so this is going to be x and x. These are positive. This is positive and this is negative, so one of these is going to be positive and one of them is going to be negative. So we need terms of 56, negative 56, that are going to add up to 8. I mean to x. To positive 1, really. So that's going to be 8 and negative 7. Okay, now we can set x plus 8 equals 0 and x minus 7 equals 0. Subtract 8 from both sides, and we get x equals negative 8. Add 7 to both sides, and we have x equals positive 7. Okay, now we can substitute these back into the original problem. And once again, you can either do it into this problem or this problem, whichever one looks easier. I did it into this problem last time, so we'll do it in the very original one this time, just to show that it doesn't really matter. So we have negative 8 minus 56 equals negative 8 squared. This is negative 64 equals negative 64, which is true. Okay? Or if we did it with 7, we would have 7 minus 56 equals negative 7 squared. This equals 49 equals, oops, negative 49 equals minus 49, which is true. Okay, so this would be your answer, and please do the checks. And that's it for this lesson. Try your practice problems and let me know if you have any questions. Thank you.